your earth bar or connection point in the switchboard to your earth electrode. Should have no more than half an ohm. This one's a pass. Check the frame, a couple of different areas of the enclosure. Okay, that's a pass. Check your earth contact points, socket outlets. Okay. Clearly that one's a fail. We know from this one from previous, if we touch it up there, it's in the active terminal. So resistance and continuity of earthing, protective earthing conductors. There's a fail on both those socket outlets. Okay. Click onto IR, 500 volts, mega ohm range for your insulation resistance. Because everything's in front of you here, it's a very easy test to do. Normally, if you're out in industry and you've got pits that are, metres and metres away, and socket outlets and the installation out within the installation, not everything's in front of you, you'd start bridging things together and all that sort of stuff. There's no electronics in this, so it's just easy to put in on your earth. Okay. I actually turn it off in this particular instance. Okay, and just go to all live conductors and points. Okay, down to earth. We'll just check the meter first. There. Okay, and we go there, 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 there. Okay, it fails IR right there. And the active conductor on that circuit breaker down to earth. So it's actually pinpointed which one it is. Okay. And that's the only area that fails IR. Okay. And so it went from earth to every live conductor or point.
What about actual consumer mains, obviously?
Yep. And if you're going to do between live conductors, you can go to the neutral here, okay, on the bar there, and go to either side of the service fuse, okay, onto these points here. And I've just done between the live conductors on consumer mains. Okay, don't need to do between live conductors on final sub-circuits. Okay, it's only from live conductors to earth. All right. Polarity. Okay, I'm going to follow and make sure my active conductor goes all the way through to where it's got to go, and my neutral conductor from the pit goes to where it's got to go. Okay, so on the 3 ohm scale, by the way, start with the actives. Okay, just quickly zero my meter again to change scale. Should be okay, but it's always like to double check. When you change scale, quite often it throws the meter out a little bit, so in that case it did. On your active conductor, where should it go from there? It should go to the top of the service fuse, okay? And that's exactly where it does. I touch it on the meter up in the neutral there. Clearly I can see it goes to the top of the fuse and not to the actual neutral, okay? So the polarity of that one's okay.
So it must goes to the top of the fuse.
Yes. Yep.
I mean, if it doesn't, I mean, that's an SIR, isn't it? Can't really,
Yep.
can't look at it.
Correct. Yep. From the bottom of the fuse, it'll go to there, okay? Good. From the other end of the meter, it should go to the top of the main switch, and it does. To the bottom of the main switch, that should switch. To the load side of the next one, that should switch. To the load side of that, that should switch. To the load side of that, it should switch. Load side of that, it should switch. Load side of that, it should switch. Load side of that. Load side of that. To the active terminal of that socket outlet, it should go there. And as we know, it doesn't go there, it goes into the earth. So there's a fault there as far as polarity goes or transposition of conductors. We've determined through our testing procedures that active and earth are actually transposed at that socket outlet. Okay? and that's all the actives from there. Okay, your boost and off peak. Okay, they go up there. Okay, there's an SIR, or the drawings in SIR show boost on the left and off peak on the right, but remember we're not expecting to SIRs. Okay, there. Okay, we come around to the other side, up here, socket outlet. I'm on the wrong one. Should be on that one. Shut it off. Okay, let's stop and test it. So there's nothing there. Okay? I've got no earth, I've got no active, so it's a dead socket outlet sitting there with nothing. Okay? Once you've done that, you've done all your actives, click it onto your neutral. Okay? And that should go to there, which it does. I might just quickly check the fuse. There's nothing there. It should also go to there. Okay? It should also go to the neutral bar, and it does. It should also go to the load side of the RCD and then switch. Which it does. It should also go to the load side of that and switch. And it does. It should also go to that. Protect the neutral bar, and it should also go to the neutral at the socket outlet, and that socket outlet doesn't have a neutral. Okay? Everyone okay with that? Correct circuit connections. There's only one socket outlet here, so I'm not going to have any ring circuits. And the circuit connections I've followed through with my polarity to make sure everything goes where. We know we've got transposition of conductors there. I know that the neutral goes there. A lot of that you can do visually through here by following the cables. Okay? Everything's in front of you. Fault loop impedance. If I wanted to do a fault loop impedance check, I simply, if you don't have an alligator clip, okay, you just bridge the active and the earth conductor out, okay, and follow it from the bottom of the circuit breaker to the earth bar. We're not going to have a fault loop impedance problem in here. Fault loop impedance is generally because you have a high resistance because of circuit runs and long runs in cables. Or if you're doing a practical assessment, often they'll put resistor packs in there or something like that. You're not going to have a resistor pack in here, okay? We're not going to confuse people by doing that. Also, the RCD is in here protecting that, so even if there was a fault loop problem, there's an RCD which rectifies the problem anyway.
Well, in this, we're just supposed to say supply not given to RCD, is that correct?
We're doing fault loop at the moment. When you do the last one, which is on the top,
yeah, sorry. Yeah.
Operation of RCDs is by an integral test device, okay, which is that one there. Clearly we can't do that because we have no supply available. Okay, and I'll probably rock that on the sheet. Operation of RCD, supply not given.
I just wanted to test when you were testing when you had the mega run, you tripped an RCD.
Well, they've got a small amount of current.
Yeah, yeah. I just wondered, is that a way to test them? Put the 240 volts on your mega, on your neutral and your main switch, and then try the test run. Wouldn't work.
No supply available, that's all we've got to run. That's all your testing procedures. Okay, testing procedures like that.